This is the second problem for chapter 18. The compactor is traveling down with a velocity of 5 feet per second when the motor is disengaged. So it means that we start with a velocity of 5 feet per second. They determine the angular velocity of roller B. So we have a roller and then the wheel. So this part is the wheel and this part is the roller. When it travels 20 feet down the plane, the body of the compactor, excluding the rollers, has a weight of 8,000 lb and center of gravity is at G. So we have a roller that weighs 400 with a radius of gyration as 3.3 feet. The front roller has a weight of 800 again with a radius of gyration of 1.8 feet. Okay. They do not slip as they rotate. This is the question. Okay, so let's call this one as a roller as well. Roller A, roller B. Okay, so then we will have the kinetic energy at 1 plus the potential energy at 1 will be balanced by kinetic energy at 2 plus potential energy at 2. Okay, and then if we write the potential energy is much easier to solve first than the kinetic energy. If you go back here, so we had a similar problem for the potential energy, but here the potential energy, so this change is 20 feet, it is given, that is 20 feet, and we know that this angle is 30 degrees. Okay, then the y distance will be this one, and that will be, this is the y, and that is 20 into sine 30. That will be y is 10 feet, and this is 0.1, this is 0.2. So potential energy at 2 is 0. Potential energy at 1 will be mg, y will be the 20 into sine 30, that is 10. Then let's find the m values. That's potential energy at 1. The potential energy at 1 will be mg, y, which is 10. The m value, we have the compactor, which is 8,000, plus the 2 rear wheels, each is 400, the total is 800, plus the front roller with a weight of 800 times the 10. So that will be 800, 1600, 9600, 96,000 lb feet. That's the potential energy at 1. Next comes the kinetic energy at 1. The kinetic energy at 1 will be 1/2. So let's first talk about the kinetic energy at 1. It will be kinetic energy of the compactor plus kinetic energy of rear wheels, so we have 2 of them, plus the kinetic energy of front wheels. Okay, again we have 2 of them. The compactor has only translational kinetic energy, which is 1/2 mvg squared. That's only the translational kinetic energy. The wheels will have rotational plus the translational. Similarly here, wheel will have the rotational and then translational. Okay, then so the M of the compactor is, let's go back to here, M of compactor is 8000 by 32.2. Then Ig of the wheel, we have two of them, but easily we can find from the radius of gyration, which is 3.3. So I will just put this one as A. So IgA will be 3.3 squared times the mass, which is 400. This is for one of them, okay? And then two of them, it will be times 2. Okay, that will be 400 times 2 times 3.3 times 3.3. Okay, 8712. Okay, so that is, this 400 is LB. That will be 400 by 32.2. Okay, that will be, again, by 32.2. That makes 271. 271 slugs and then feet squared. That's for Ig value from both of it. Similarly here, Ig, the B will be 1/2, the radius of gyration, which is 1.8, and the mass is 800. So radius of gyration is 1.8 squared times 800. That will be 800 times 1.8 times 1.8. That makes, and divide by 32.2. 81. Divide by 32.2. That makes 81. Okay. This is for the radius of gyration. But the question is that we need to relate these velocities and then omegas to this velocity here. We have to relate them. Okay, and then let's do that. Okay, so the Vg value as always omega into Rg. Instead of omega, we can write the Vg by Rg. Okay, so that's what we can do here. And then the question says that the velocity is 5 feet per second. So state 1, Vg is 5 feet per second. Okay, then here it will be that 5 feet per second by the radius. For the rear one, it is 3.8. For the front one, it is 2.2. Okay, so then rear 3.8, then omega front, it will be 5 by 2.2. Let me check. 2.2. So that will be that. 5 by 3.8. That will be 1.3 radians per second. And then the front one, 5 by 2.27. Okay, so that means that kinetic energy at 1 will be equal to, so 1/2, so this one will be 5 squared, and this one is 5 squared, and this one is This is for the rear wheels. Okay, the rear wheels was 1.3 squared, and this will be the front ones 2.27 squared, and then again 5 squared. Okay, so let's find the terms. So let's calculate one by one. So the first one, so I will just 1/2 0.5 times 8,000 times 25 by 32.2. So the first term makes, so 3106. That's the first term. Next term is, so let's calculate it. It will be that 0.5 into Ig, which is, so let me calculate. I believe I calculated the Ig value and then I deleted it by mistake. So 3.3 times 3.3 times 800 divided by 32.2. That makes 271. So this is the Ig value. Okay. And then it will be that 0.5 times 271 times 1.3 times 1.3. Okay, that makes 229 plus the second term, which is 0.5 times the mass is total mass, which is 800 times 25, and divide by 32.2. So 310. Okay, so this mass is 800. Okay, so let me just do one more time. 0.5 times 800 times 25 divided by 32.2, and actually it is 11 divided by 32.2. Okay, so we have the first term, we have the second term, and then comes the last term. So that will be 0.5 times 81 times 2.27 times 2.27. That makes 209 plus the second term 0.5 times 800 times 25 divided by 32.2, 311. So we have all the terms, we can calculate it. Okay, so it means that that will be 300,016 plus 229 plus 311 plus 209 plus 311. Okay, 4166. Okay, so that means that kinetic energy at 1 will be 4166 lbf foot. Okay. So we just found the kinetic energy 1. Potential energy 1 is also there. Kinetic energy 2 is unknown. Potential energy 2 is also 0. Okay, so let's write all the terms together. So kinetic energy 1 plus potential energy 1 will be kinetic energy 2. This one was 4166, and this one was so mg into 10. Mg is the total mass, which includes 8,000. I believe I calculated this somewhere. Okay, so this one. So 96,000. So plus, okay, plus 96,000. That will be kinetic energy at state 2. So let's add them. So 100. So this will be And then from here we will find the velocity in the next recording.